first session. It's a great pleasure for me to be able to introduce our first keynote speaker of CLE 2010, Professor Norbert Fuhr. Norbert obtained his PhD in '86 from the University of Dortmund, and since 2002 he has been a full professor in Duisburg-Essen. Now, we know Norbert from his extensive work on retrieval models, on digital libraries, on user-oriented retrieval methods, and on the evaluation. And you know, that work has led to a large number of papers, a large number of highly cited papers, through which we've been able to find out a lot about Norbert's ideas about retrieval and about retrieval as a science. Now, these papers were complemented by another big addition to, or contribution rather, to the community, namely Norbert's initiative to set up INEX, the Initiative for the Evaluation of XML Retrieval. So INEX is a place where you can see lots of creative ideas being developed around using structure in one way or another to improve information access. Today, we're starting with CLE 2010, CLE in a slightly different format where we complement the labs, the experimental work with a conference part which is aimed more at reflecting on these experimental activities. So in that light, I'm very happy to announce Norbert's talk, which is exactly on this theme, namely the IR between science and engineering and the role of experimentation. So let's welcome Norbert.
Thank you, Maarten, for this kind introduction. Well, the title of the talk is a bit lengthy, so to give you a better impression of what this will be about, I'd like to start with a joke. A man walking his dog late in the evening suddenly notices a person who's crawling on hand and feet under a street lamp. So he approaches the person. "Can I help you?" "Yeah, I lost my keys." "Okay, let me help searching you. Where did you last see your keys?" "Over there, in front of my door." "Then why are you searching here?" "Because it's better light over here." So, in terms of this analogy, my talk will first start with the light, and later I'll try to talk about where we might find the keys. So I'll first talk about weaknesses of current evaluation practice. Then a major issue will be about IR in context. And finally, I will try to point out some directions for future research in our area. So, talking about weaknesses, I would like to address 4 issues, namely, first, some shortcomings of the system-oriented approach, improvements that were claimed but that don't add up. Then talk about metrics, about the difference between significant and substantial, and finally, the user will enter in our discussion. Well, improvements that don't add up, that was a paper presented last year by Armstrong, Moffat, Weber, and Sobel at the SIGIM conference, where they performed an analysis of 106 SIG-IR and SIGIM papers on ad hoc retrieval, which used track test collections, and all these papers claimed improvements over previous results. Now, their findings are summarized in 2 plots. So here we have the results for the track 8 ad hoc runs. On the left, we have the mean average precision. And here on the top, the thick black bar means the best track run, best official track run for track 8. Then we have here the best title-only track run, that's the third quartile of the track runs, and that's the median of the track runs. Now, the colored plots here in the center of the figure, they show the experimental results published in the SIGN and CKR papers. There were 32 of them. And for each experimental study, we have a pair of points here. So this gives us the year. And then we have a pair of points where the cross denotes the baseline used in that paper. And the other symbol, the circle, triangle, or square, denotes the improved results by using the method proposed by the authors of the respective paper. And the two results are connected by a straight line. Now, contrary to what one would expect if you do experimentation on this track collection, the natural choice of the baseline would be the best run, the best official run from track 8, which was in 1999 or 2000. But actually, none of these studies used this baseline. Instead, we see that it's only, only a few of the papers actually used a baseline that's in the upper quartile of the official track runs. And there are even many papers using baselines that are below the median of the official track runs. So it's no wonder if you choose a poor baseline that your method will yield some improvements. But in fact, none of these papers actually was able to beat the best track run. Well, with two minor exceptions, well, these two studies, they actually were able to beat the title-only results. And the other interesting thing is that regarding the tendency over time, one would assume that over time, at least people would use a better baseline. But this figure tells us more the contrary, that over time, people choose weaker baselines in order to demonstrate the feasibility of their method. So we can see that, in fact, none of these improvements really is able to beat the best track results. And they applied the same analysis on results performed on experiments performed with the track 7 ad hoc results. And here there are actually two studies which were able to beat the best track run, but the majority of the runs still uses very weak baselines. Yeah, many baselines are below the median of the track runs. And so overall, we see that the outcomes of these studies are more than questionable. So to summarize the results by Armstrong and his colleagues, they found out that over 90% of the papers that claim improvements exist. These improvements exist only due to poor baselines, but they do not really beat the best track results. Now, one might argue that maybe, well, even if you are in your actual study, you were not able to beat the best track results, maybe at least you showed a way for improving one method for improving retrieval quality, and so you just should try to combine the different methods giving better results in order to beat the best track runs. But in fact, Armstrong et al. Found out this is not the case. The improvements just don't add up. Like there's the saying, there are many ways for getting to Rome, but in terms of this analogy, it doesn't help combining these ways. You just don't get better result. So Armstrong et al., they claim that, well, this is rather poor finding about the state of this type of research. And they say, well, what we need are standardized benchmarks, like, for example, in the database field, there are standardized benchmark runs, and there's an institution registering these benchmarks and checking that you did everything right. And they started setting up a registry of runs, but unfortunately this hasn't been used very much so far. So the idea is to set up a registry of runs under standardized conditions, so whenever someone publishes a new result, it can be automatically checked under which conditions this result was produced, and if it really is an improvement over the best results published so far. Unfortunately, so far this idea hasn't really been taken up. And so we are still living with these pseudo improvements in terms of system-oriented approaches. Well, next point I want to address is the issue of measurements. Well, here I have a plot showing the rank and precision values, and now assume that we have two systems, the red one and the blue one. Now, of course, if we look at the user, then, for example, users who only are interested in the very first document, like, for example, many web search users, they would just click on the first result. Usually, for them, precision at 1 would be a good measure. Some more sophisticated users might even look at the first 5 results, so precision at 5 would be the more appropriate one. And if you go further down to 10 or 20, which is a rare case on the web, then the corresponding precision values would be appropriate thing. Now, depending on what your user group you are focusing at is doing, you should choose the appropriate measure. So to say, for users looking only at a few documents, then of course the red system would be the system of choice. But for those users who want more documents, then the blue system would be the better one. So that's the general idea. Now, what is usually done in information retrieval evaluation, standardized track measures, is that we are averaging over user populations. Now, what is regarded the mean average precision computation starts with looking at the precision at relevant ranks. So assume these are my, I have 9 or 10 relevant documents found at these ranks. And for each of the ranks where I found a relevant document, I compute the precision. Now, for mean average precision, in order to give it a user-oriented interpretation, we assume that at each relevant rank, the same proportion of users will stop searching. So in this case, 10% of the users will stop at the first relevant document, and also at the very last relevant document, still 10% of the users will stop. Now think how realistic this assumption might be. I think it's quite obvious that a more skewed distribution over the users would be more appropriate. But the mean average precision instead assumes this equal distribution over all the relevant ranks, and then we can compute the average precision based on this assumption. And mean average precision then is just the averaging over all the queries in your query set.